I always say once you introduce significant amounts of software, the number of states that your device can inhabit becomes combinatorially huge. I think there are devices out there that have more states than there are atoms in the universe.
None of this AI capabilities that we've seen, especially the LLMs, would be possible without open content and open source.
Do you guys think that eventually AI is going to automate away the programmers, the software engineers?
My general point is, who cares? It's in our job as engineers to solve problems. If we're solving problems, there's going to be more problems. I guarantee you that problems will not go away. There will be problems for eternity. And so from my perspective, even if AI comes and automates all of our software writing process, I hope the software that the AI produces is open source.
Welcome to Coredump Sessions, the podcast for IoT leaders, firmware engineers, and embedded systems enthusiasts. Each episode, we bring you insights from the leaders and innovators shaping the future of connected devices. We'll talk about what's breaking, what's working, and what it really takes to build reliable products at scale. Let's jump in.
And we're live. Welcome, everybody. So I'm François Baldassari. I'm the founder and CEO here at Memfault. I'm an embedded software engineer, but nowadays I mostly do Excel and emails. That's my life. Joining me today is Thomas Sarlandi, who's our field CTO and head of products here at Memfault. Thomas is an entrepreneur. He's an engineering leader. And luckily for me, he's a 2 times colleague for me since we worked together at Pebble, where he led engineering and before that developer community efforts. So welcome, Thomas. Very excited to have you today.
Hi.
We also have 2 folks from the great team over at Goliath. First, Jonathan Berry is joining us. He's founder and CEO at Goliath. Jonathan has more than a decade of experience building IoT solutions at companies you've heard of, like Google, Particle, WeWork, and a few others. He's been building IoT platforms for years now, and he's a friend and a peer in this industry. Welcome, Jonathan.
Thanks so much. First time caller, long time listener.
And we've got Dan Mangum, who's the CTO at Goliath. Dan is an experienced engineering leader who's built products at both large and small companies and has a history of leadership and contribution in a few notable open source communities. Welcome, Dan.
Thanks. Glad to be here.
Okay, so AI, open source, and the future of embedded development. AI, I think, is the headliner in many ways. It's the thing that's on everybody's lips, right? At Embedded World, it was on every booth. Everyone's talking about it. So why are we talking about AI today? John, do you want to get us started?
Yeah, I mean, it's amazing. There's been so much innovation, investment, but in some ways it's something new that's been almost here for 25, 30 years. When I talk to the semiconductor folks, all their analog people are like, these MPUs are just analog ASICs, right? But of course, we're all, as users and part of the world of AI seeping into everything. And I think it's the culmination and maturation of general applicability of AI is now making its way into all corners of industry. And we really are seeing it being adapted in multiple fronts in our world of embedded.
Thomas, what does AI in the hardware context mean to you? I think AI is such a broad term and a grab bag. What do you see as the most interesting AI applications and use cases?
I mean, I think, the fews that many of us saw were models running on tiny microcontroller. I think we've seen that for 6 years, maybe even a little longer. There's been a number of projects there, voice recognition, some data processing at the edge, where the goal was to do the processing on the device so that you don't have to stream all the data back to the cloud, be able to use models in environments where you don't even have a connectivity sometimes. And so that was the original model. But I think when we talk about AI today, like we're all super excited about vibe coding and using ChatGPT to parse data sheet. And that's the other way where, we're really talking about LLMs and LLMs coming into the world of the embedded engineers and changing the world of the embedded engineers, both during the development phase, but also at execution phase, like once the project is in production, is using AI to process data collected from the devices. I think there's many angles of AI that we can discuss today.
Yeah, so there's AI at the edge, which, as you mentioned, has been around for a long time. I remember at Pebble, we got pitched some microcontrollers with neural accelerator units already, right? So that was 2015. It's not 6 years ago, it's 10 years ago. So that's been
Yeah.
around for a while. I think people like things like wake words. Maybe Dan, you have some use cases that you also remember, but things like wake words have been using tiny little, neural networks for a long time. Then there's the LLM, elephant in the room, which I hear from you is more of a dev tool in a way. Like LLMs used to develop IoT devices, to develop firmware. Are there any others? Dan, is there any other AI use cases you want to call out or anything you want to add?
Yeah, I mean, I feel like that, it ultimately, with any of the AI capabilities, it comes down to like finding the right tool for the job and then doing it in the right place, right? So we have a lot of customers that leverage AI on devices, a lot of customers that leverage AI in the cloud. And when you look at something like an LLM, that's kind of a general purpose hammer to some degree. You can kind of throw anything at it and just kind of like paint context around it with your prompts and things like that. So maybe not the best use case, right, for running on a device. And actually, you're going to be pretty hard challenged to find an LLM, a very capable LLM that's going to run, at least on microcontroller class devices. If you're doing, something like WakeWord is a great example, right? Because it's a very focused use case. Those are the sorts of things that, you either don't have the latency to be able to round trip that type of thing to the cloud, or it's just not something where you'd want to upload a ton of audio, right? It can be more efficient to perform inference at the cloud edge rather. And so for us, a lot of the kind of like AI hype is not, hey, is AI useful? It's where do we actually want to execute it? And what type of models are things we want to use. We also have a couple customers, I'll be honest, where they're very excited about using AI, and there are much simpler statistical methods that can be leveraged to accomplish their use case. And a lot of times, one of the deciding factors there is how much determinism do you need in your product, right? Because models are inherently not deterministic in many cases, or most models are not. So that can also be a factor. So if you're in a safety critical context or something like that, you can't rely on unreliable output.
Kind of
Just-
like how much chaos do you want to introduce into your product? I love it.
right, exactly.
Yeah, though,
There's
if you have software, you already have a good amount of chaos, right? The number of I always say like the once you introduce significant amounts of software, the number of states that your device can inhabit becomes combinatorially huge. I think there are devices out there that have more states than there are atoms in the universe. Like it's just the numbers are mind-boggling, and therefore the idea that traditional software is deterministic and AI isn't, that traditional software is testable and observable and analytically solvable and AI isn't, is actually, I think, overplayed to some extent. Nevertheless, we have less experience with AI, and so we're a little bit more cautious. I think that's fine. Thomas, you were about to say something. I interrupted you.
Jonathan, I think.
Oh, yes.
Sorry.
Oh, yeah. There's another category of application of AI, which is around operations. And, we're starting to see companies use, whether it's some form of analytics, like your fleet is misbehaving, or anomalous behavior. Can I ask my fleet how it's feeling today? Those kind of like chat agents. And I think it's very early in this. There is another wave, because we were talking about waves of coding and how that's applying to embedded. This like agentic AI of actually taking action. It's kind of wild to see roboticists and sensor people showing up to NVIDIA's conference, because like people are building robots with LLMs and it's actually embedded systems and working with sensor data, but the world doesn't translate easily. For example, we looking at time series data, sensor readings. There actually aren't really good models for time series data. Do you think it would be easy because it's structured, it's categorized, and so there's a lot of, I think, early days of applying general purpose LLMs that have been specialized for other domains for this agentic purposes into IoT fleet operations. But I think that's also a trend that we're going to see evolve over the next couple of years.
So you bring up a really important point, which is we mentioned AI at the edge. Been around a long time, actually, training small models to process data that's coming from the sensors for latency reasons or for bandwidth reasons. And we think that that's really well matched to embedded use cases and actually fairly mature technology, right? Like both, Infineon bought a company that does that. ST bought a company that does that. There's a number of framework to do that work reasonably well. Number two, we talked about AI as developer tools for writing codes, documenting codes, reviewing code. Potentially, I think there's a company called JTEX that does AI for board layouts and schematic capture. There's a company called Diode that is trying to do AI-enabled full device development, right? So that's kind of AI in the development phase. And then, John, you brought up AI in the clouds, AI to enable devices from cloud services. And I think actually that's going to be the most common use of AI in IoT devices, which is you'll have some AI system in the cloud that the IoT device feeds data into because it's easiest to run a complex AI system in the cloud. We already have all the infrastructure to do it. And in fact, there are many companies that are already doing that. Anomaly detection is, there's anomaly detection AI systems that have been around in the cloud for a really long time now that folks are using. So today, of these three things, first, if I'm missing anyone, feel free to add more of these categories of AI use cases. But of these three that we're seeing, that we're talking about theoretically, are there some that you're actually seeing broad adoption of? So for example, I would say that although I'm a big believer in AI software development, and we'll talk about that in a bit, I'm not seeing broad adoption in embedded software yet. I'm not talking to all of our customers and hearing from them, I'm writing 50% of my code with AI, right? But where do you see the real adoption? What are the things that your customers are already doing in production versus
Yeah.
things that they're just excited about?
Yeah, I think I think Dan kind of talked about it. We see a big mix of people excited about AI at the edge and increasingly deploying it. We have a case study with a company where I think it makes the most sense. Computer vision is a really hard problem. If you have a low latency application like wildlife detection, deterrence with one of our customers' flocks, it's a lot of work to go build that out. And in fact, there are off-the-shelf, ready, available frameworks for doing computer vision on device for detection. And so where there's complicated sensors that there's no easier path or there's more mature audio, wake words is a good example, but the actual processing of the audio can't be done on the device. So you basically always send it to the cloud. But we do see recurring patterns. Any of this rich media applications where you can reduce latency, reduce the data you send to the cloud for pre-processing, those seem to be where they start from edge AI. But for those other two categories, we don't see a groundswell for sure.
Completely agree that audio video use cases are today very rapidly adopting AI, whether that's home security or, we've talked to companies who do use cameras to detect flares on, oil and gas sites, things like that, like very rapid adoption of AI models, both at the edge and in the cloud for those use cases. And if I were an engineer working on those kinds of applications, I would want to become very acquainted with solutions. Thomas, any other real world AI use case you're seeing?
Yeah,
Actually in production?
I mean, I'm gonna plus one everything you guys said. I think audio and video at the edge is now pretty mature. It's so much that I don't know if we should really call that AI, but like I was just checking, NVIDIA came out with the first Jetson board in 2014, and I think they've really pushed really hard the adoption of AI or at least video processing at the edge. And now we see a lot of customers deploying Jetson in the field with Linux embedded devices. We have tons of customers with them, with some models that sometimes are super simple and models that sometimes are really a lot more complicated. And I think the challenges these people have are often related to the fact that they're taking code that is often started as a Python project by a researcher who's not an embedded engineer, and then trying to productize that into an embedded
MATLAB.
product. Sometimes people
MATLAB. I mean,
yeah.
at several of my jobs, MATLAB was where the AI was developed. And then, people thought you could click the button to turn it into C, C++.
And just run
Not
it.
so sure
Yeah.
about that.
And so we see people like that still, and then they're having trouble figuring out how to update it, how to monitor it, how to capture the state so that when it does not behave as expected, they have a way of debugging it. That's very tough. But yeah, I don't think LLM have been strongly adopted in the hardware world yet, with the exception of, the plethora of projects that we saw last year. And I think there's kind of a lower number of those, but there's I remember going to a AI meetup in San Francisco and seeing a lot of different pendulum, that would record your conversation all day, stream them to the cloud, or wrist-worn devices. There were like at least 3 different devices that all had the same goal of transcribing all of your interactions throughout the day and giving you a summary at the end of the day of who you talk to and what are your to-dos. And that was really interesting, but I don't think any of those is really become mainstream yet. And I think for our customers that are more established, AI is moving and LLMs are moving so fast that it's definitely really, really challenging to think about how can you design a product today that's going to ship at best in 9 months and integrate LLM into it. If you don't put the LLM in the cloud, it's really, really hard to think about how you're going to design the product and work.
Should we talk about the LLM hardware?
I think we could. Yeah. You want to talk about it?
So Dan has some experience with it.
I'm not sure what Jonathan specifically is referencing here, but
So this trend of LLM based devices, consumer devices, high cost, high profile, right? The Rabbit R1, the Humane Pin, I think kind of speaks exactly to what you're describing, right? Like there was a big promise of these devices, purpose-built devices that, in all accounts, like pretty amazing embedded devices, but we're just calling ChatGPT for a REST API call. Like that was mind blowing for us, and we started digging into some of it, and that's what I was teeing up for Dan.
Yeah. The LLM hardware threw me off there because there's actually, no LLM running on the hardware for all these cases. But no, I think that's a good point. And the main thing that we've seen with folks who want to leverage that is the pace at which the models are improving. Building a product based on that is really challenging. Being able to just swap something out in the cloud is infinitely easier. I know, both Goliath and Memfault are big advocates of every device should be able to do OTA updates. So that should allow you to improve your product over time and even deploy new models without doing a full firmware upgrade. So that's certainly something that we encourage. That being said, despite the capabilities that both of our great platforms offer on that front, being able to do a one-line change to swap out the model that you're using when calling OpenAI is going to be a lot easier than doing a model deployment. The other thing that's tricky is a lot of the value for connected devices and AI is that you have data that is highly unique, right? That's one of the benefits of having large fleets of devices is, similar to how like someone like Google has a ton of data on internet, usage and that sort of thing. Your kind of secret sauce as a connected device product maker is that you are acquiring data from places where no one else is, right? So even if you have competitors in the same space, you have a unique data set that you're generating there. And so for us, there's been a lot of education on just getting that data off the devices into a place where you can start to leverage it, whether it's for inference or your own model development. Because a lot of these companies that, they're worried about electrical engineering, firmware, building a cloud platform and that sort of thing. And being able to also build out a team that's doing model development is going to be super tricky. So actually getting data into a place where you can develop your own models or feed it into existing models or maybe both is something that we've been working with customers a lot on. And actually, Jonathan mentioned the case of the company that's doing animal detection. Well, there's not actually a great data set for, animals that are out in the wild, right? You might be able to detect household pets because that's a readily available data set, but maybe not as available as detecting a moose, right, on a runway or something like that. So for them, there's actually somewhat of a necessity of doing model development because they have a unique data set, or maybe just model fine tuning in that case.
Both you and Thomas mentioned that there's some challenges with encapsulating LLMs in a hardware form factor, and that's how fast the space is moving. Very, very hard to design and bring to market a hardware device when the underlying technology changes every 2 or 3 months, because by the time your form factor is ready, you've done your EVT, DVT, PVT build, you're mass producing the thing, the entire capability set available to you has changed completely in ways that you might not have been able to predict. And I think that's one of the reasons these hardware plus AI companies are falling flat on their face, is like by the time they're actually in mass production, they're old news. Like the state of the art has moved much further. And that's challenging for hardware companies. They'll never move quite fast enough. I want to talk about writing code with AI, because that's I think it's something that, whether we like it or not, is happening. And I think a lot of engineers, a lot of companies are trying to figure out what their policy should be. I mean, at Memfault, we have this conversation. Like, what should our policy be? How do we enable our engineers to leverage the productivity enhancing technologies without introducing IP and other kinds of risks? Obviously, we're not lawyers here, but I'd love to hear your point of view. And have you had much success using AI to write code, firmware code, cloud codes? Are you optimistic? Where do you see the risks? John, why don't you start us off?
Yeah, it's been really interesting to see. Part of the conversation here is around open source, and I've been involved with the Zephyr project for some time. In one of the last year, they were already starting to ask, should we accept pull requests that were generated with AI? How do we know if a bug report is from a human or not? And so I think whether you're a company, an individual, student, this is definitely top of mind to everyone. I'll start maybe on the embedded side, just because we were looking at this more recently. In fact, a lot of the embedded code is not great that we've seen, and I think there's a lot of reasons for that. Where web development code is truly there, and mobile as well. Our head of product, who is an engineer, wanted to build this web app idea during a hackathon, and he used V0, built the whole thing with UI, with tests, deployed it by himself, and that's not his, doesn't write front end development for his day job. But we've seen on Hacker News and on Reddit people doing some Arduino prototypes and ESP-IDF prototypes, but they're all not great. And so I don't know if that's an indication of the future, but currently right now it's not the best tool for writing embedded software versus like a web app. I don't know, for the front end engineers in the audience, like, your job is fine, but there are other people doing it pretty well, and I don't see that the case, at least for now, on the embedded side.
I think it's interesting to think about how not just like the connection between open source and AI, but also how the fact that Zephyr, actually everything you mentioned there, Arduino, Zephyr, ESP IDF, right? These are projects where there's a lot more code available to train on. And so I'm actually interested to see from an end user perspective if I think, to some degree, folks are already starting to see the benefits of open source firmware and building on these open source platforms. But I also think that as AI continues to improve, when there are lots more examples available for these open source projects, that's actually going to drive a lot of folks, especially maybe newer folks, to start using those projects. So even if AI specifically is not like driving those projects forward, it might drive more adoption of those projects. I think a good example is like, if you've ever written a
Really
Zephyr,
interesting insight.
yeah,
Interesting insight. Keep going.
if you've ever written a Zephyr driver, there are intricacies of, all peripherals that you interact with that you're going to have to look at the data sheet for. And by the way, there are companies doing like data sheet analysis and that sort of thing. I don't think in my experience that like more general purpose LLMs are super great at that, unless if you can provide the data sheet and it can do some analysis and that sort of thing. But the thing that it is really great at is doing the templating and, instantiating all the macros that you need, because it has 1,000, 10,000 examples of doing that, right? So it's really easy for it to pull that together. And there is a lot of boilerplate in embedded code, especially if you're doing something like driver development, where there might be hundreds or thousands of instances of that being implemented. So I think in those areas, it's really interesting to see, like, are we going to see more, faster driver support? Are we going to see more products built on Zephyr? Are we going to see more products built on ESP IDF, because it is such a great enabler there?
Yeah, love the insight about the platforms that are the most open will be the best to develop with AI, and therefore may end up winning out just from that. I think that's really cool.
Yeah.
Wouldn't it be ironic if they didn't accept pull requests though?
Like, Thomas?
Yeah, no, I think on that topic, the world of embedded Linux, which is what I'm seeing the most here, because I tend to work with our Linux customers at Memfault. They're really able to use more AI maybe than our customers that are using esoteric platform, because there's so much more code in the Linux open source community that can be based off. And, embedded Linux programming or systems programming, there's the very thin line. It's kind of the same thing to some extent. And so there's maybe a lot more code, and maybe that's why we're seeing more success and more adoption there. There's some tools that we're using at Memfault now that will automatically review pull requests and add comments on pull requests. And sometimes the comments are really not that relevant, but, I've also seen some pretty accurate comments, and that's on Rust code, which is already strongly typed, has already be a lot of safety built in, but you can see the insights by the AI just looking at the code, and you're like, wow, it actually did some thinking there to come up with that warning in the pull request, and that's very relevant. And so I love seeing that, and yeah, I think the Linux embedded world can definitely use vibe coding today. I think that's an option.
We made a difference, or we separated AI authorship from AI, I would say, enhancements, right, of our software developments. There's the AI authorship piece, which is, what some call vibe coding, which for those of you who've never heard the term means asking the AI to write the code. Say, write me a driver for I2C that's compatible with Zephyr, and it spits out the code. And vibe coding specifically is when you don't even look at the output. You just compile it and run with it. So that's one side. And we're generally skeptical of that today. Although, by the way, I would bet real money that the majority of Arduino projects being started today are AI coded. I would bet that it's more than 50% today because of the.
I absolutely recommend that people do that. If I meet someone who's like, hey, I'm building this, there's so many people like artists, that are, that's where Arduino has been so good in the beginning,
Yes.
is the mix of Arduino and the processing language and artists using Arduino to build statues and stuff like that. I would absolutely recommend that those people use AI tool to vibe code whatever they want. And I think they're going to get good results because there's so many Arduino code on the internet that the tools are going to be able to get you there. Maybe the part where it's going to be the most difficult is connecting the tools together. Because if you're just using ChatGPT or Claude and copy pasting into the Arduino IDE, and then clicking compile and copy pasting the error back into Claude, it's going to be a slow development cycle. But if you use an Arduino plugin into VS Code and then use something like Cline, where you can actually compile directly in VS Code, get the error back into the model automatically, you're going to move much, much faster. I think today that works.
Actually, I think you're hitting on one of the key points. It's the integration. The integration engineering is the complexity part, right? And in fact, this is good timing for this webinar. Last week, Arduino announced their cloud editor now has a native Claude integration trained on Arduino code, right? Like,
Makes perfect sense.
that makes perfect sense. It's a good use case. If people are doing it manually, why not automate that? And I think that's where we're going to start to see more and more utility being generated for the AI assistant, right? When it's not just a Cline, but it's a NRF Connect SDK, which integrates, an AI assisted tooling, or Modus Toolbox with integrated AI tooling. I think it makes sense for a lot of the semiconductor vendors to invest in this, even if it is proprietary data sets that they have. I mean, they have all their internal reference designs and custom applications, but it's until it becomes an integrated experience, I think it's going to be just very difficult to get that feedback loop necessary to be successful.
So we talked about the authorship piece and how that's, a work in progress, I would say. But then there's the engineer enhancement piece, right? Things like copilots, which are basically AI-powered autocompletes or automated AI code review, these kinds of systems. And I think today these systems are ready for prime time. They're good enough for things like autocompletes. They're good enough for things like code review. They don't have a 100% hit rate, but they don't need to. Frankly, our colleagues don't have a 100% hit rate on code review either. Right? And additional AI eyeballs just only makes our code better. I also think automatically generating tests. I mean, let's be honest, mediocre tests, as long as it passes, reliably, as long as it's not flaky, is better than zero coverage. And AI can actually do that for you. I think that there's already pieces in these enhancements, not in writing the mission critical code. I'm not an advocate for that today. But in writing the code that goes around it, the test harnesses, in inspecting the code, reviewing the code, autocomplete type use cases. I saw Chris Merck mentioning that Copilot has been a huge way that he's improved his wrist and arm health by not having to type as much. I think that's those use cases are ready for prime time. And to all the engineers who are listening today, I would say that you must start using these tools. Maybe this is a strong statement, but as we said, things are moving so fast that if you don't become proficient by using some of the tools that are ready for prime time, then by the time you come around to thinking, maybe I'll check out this AI stuff, the people who've embraced it will be running circles around you. And I think that's a career risk. In this industry, we know that the way you remain relevant is you stay at the cutting edge, because the cutting edge becomes what the expectation very quickly. So not for mission critical authorship, but yes, 100% in your developer workflows, you should be using AI. I mean, the idea that you can have AI verify your register maps using a data sheet, that is amazing, right? You feed it the data sheet, you say, review my code, make sure I didn't mess anything up. That, I mean, incredible. I wish I'd had that before.
Yeah, I
And
mean,
I think there's also one more use case is like automatically porting code or adapting it from one environment to another. There's a lot of tedious work like that in embedded where you're like going from one microcontroller to another, or one driver to another, and the AI is kind of a super powerful refactoring tool, and people should be using it for that too.
I
feel
want
like
to go ahead, Dan.
I was just gonna say that Jonathan knows this sentiment I have a little bit, but um, one of the things that always kind of surprises me about any of the AI discourse when it comes to development is like generally, at least our organization and most organizations, I think a good style of engineering leadership is like being outcome based, right? We don't dictate how you do things as long as you are able to produce them, because people are different, right? And engineers work in different ways. I think I would agree that for a majority of folks, AI tools are ways to improve productivity and have better output, higher quality output, faster output, right? That's that type of thing. And so, like, the idea that we would say you absolutely have to use AI or you can't use AI, it's like, I'm not going around to engineers on our team being like, have you considered changing what IDE you're using? You know what I mean? Like, we're not focused on your tools. We're focused on how you use your tools to get the job done. And I think, it's incumbent upon all engineers to constantly be sharpening their skills. And one aspect of that is being aware of available tooling. And sure, like, tooling is moving at a rapid pace with the introduction of copilots and things like that. But it's the same story it's always been to me. And that, like, it's incumbent upon you to make sure that you're using the tools that allow you to, do your best output. And so, like, it's same story as always with these tools as it's been for all the other ones.
On that note, I'm going to take a question from the audience on AI before I move on to talk a little bit about open source. Minal asks, do you guys think that eventually AI is going to automate away the programmers, the software engineers? And he said, serious question. And by the way, I think it is a very serious question. Who wants to take a crack at that one?
I would love to.
Go ahead, Dan.
I feel like this is what engineering teams are talking about everywhere right now. My general point is, who cares? It's in our job as engineers to solve problems. If we're solving problems, there's going to be more problems. I guarantee you the problems will not go away. There will be problems for eternity. And the way that we solve them, the tools that we use to do it, and whether we're hands-on keyboard but instructing something else to do it, I don't think that when we introduced higher level language, well, actually there probably was pushback with lots of higher level languages, but I view a different interface to problem solving is still a form of engineering. And maybe the quality will get so good that engineers look more like managers do today, and you're managing a bunch of AI engineers or whatever you want to call them. But those are still tools at your disposal, just like a computer or a processor is a tool at your disposal. So to me, like, will engineers go away? No. Will the way the job changes and will look very different? Quite possibly. But, to your point, right? Career development and making sure you're on the cutting edge is always something that we're doing. There will be jobs available for people who like to solve problems, who like to have an engineering mindset. And, if those are the things you like, you're going to be able to do that forever is kind of my take.
Could not have put it any better. Dan, thank you. Great answer. What I would add is that I've been writing a good amount of code myself using AI for the past few months, mostly web codes, like little tools for my team. Like, for example, I wrote a little org chart editor so that we can track the org chart of our customers. It took me like an hour and a half of work. It was awesome. And my takeaway is that you cannot just build me an org chart tool and get something happy on the other side, because actually designing products takes thinking and work, and also architecting where do you want the data saved? Do you want it to be possible to drag and drop things on the org chart, or do you want to edit with modals? Like, all of these questions are engineering questions and design questions and product questions. And ultimately, even the best AI won't be able to fully guess your intents, and providing a reasonable spec that can be implemented and then breaking it up into individual chunks of work is hard engineering work. And so I found that naive using of those tools leads to poor outputs, but expert use of those tools by engineers leads to incredible outputs. And so it's, to your point, it's going to be a different type of engineering, but it's still engineering. Now, do I think we'll be writing actual lines of code in an editor in the future? I don't. I think that will go sooner or later for 90% of the code that is written out there. But it doesn't mean there won't be engineering work.
As a last comment on that, I was listening to a podcast about completely unrelated things to what we're talking about today. Go to market, sales, and they're having the exact same conversation with the exact same consensus at the very end, right? If you're doing marketing, the landscape of marketing has fundamentally changed, but marketers are still critical to business and will continue to be critical to business. Sales is looking different. And all these other parts of knowledge work is just evolving, just like it's evolved for the last 30 years and will continue to evolve. So I think that's
it might be denial, it might be wishful thinking, but that's where we are landing today.
I don't think so. I mean, if you look at aviation and the way planes were designed, 50 years ago, where engineers would line up in a room and you would have 8 by 16 engineers in a room, and they would all be drawing parts, with protractors and special table and pen. And that's how they design and build pen. And if you had told them, the computer is going to replace that, and one guy is going to do the work of 16, they would have said, you're crazy. I think it's very similar. I agree with everything you guys have said.
So talking about open source, which was, the second topic here, I'm going to connect the two topics and maybe say something controversial, but it feels to me like open source is finally arriving. It's finally becoming mainstream in the hardware world. We're seeing huge adoption of open source RTOSes. In fact, you'd be hard pressed to find a popular closed source RTOS these days outside of mission critical, safety critical use cases. But at the same time, AI is emerging and potentially making it possible to make very custom code much more cheaply. Is open source arriving too late? Is AI going to make open source in hardware moot? Are you optimistic about open source? And where do you see the biggest leverage for open source technologies in the hardware space? Dan, why don't you get us started?
Yeah, so this is a bit of maybe a tangent take, but I think that open source is valuable for a number of reasons, and some of them are maybe less apparent. One that I think is incredibly important is learning. So, there's a couple different ways to learn how to be a good engineer. You can go to school and study, you can work at a company and have mentors and that sort of thing. But by far, the lowest barrier to entry is opening up your laptop and going and looking at implementation of things and playing with it and changing it and iterating on it. And, from that perspective, I think to a lot of folks, for, some reasons or another, embedded software and hardware feel more complicated. That's something that I feel like myself, coming from more of a cloud computing space into kind of like more of a hardware and embedded focus. That's a sentiment that I get from a lot of folks that I talk to who are still kind of in that world. And I don't actually believe it's fundamentally harder. What I believe is there's less access to it, right? So if you haven't been exposed in that world, like Jonathan was talking about, the capabilities of AI models with front end development. And generally, like if you look at the folks who transition from other careers into front end development, I actually don't believe it's easier. I just think there's a lot more access to it, and open source drives a bunch of that. So in my mind, open source is like never too late. It's like it can't be true, because more access and availability is going to bring up new engineers who create new things, who drive new things forward. And so from my perspective, even if like AI comes and automates all of our software writing process, I hope the software that the AI produces is open source, right? Yeah. So that's kind of where I'm sitting with it today.
Thomas, open source in firmware and open source versus AI. What's the place for open source in this rapidly changing world?
So, you talked about training then, are we only interested in training the models possibly in the future? Like that's the question. I think the one thing I really like about coding with AI is that the model is not scared of implementing things from scratch. Sometimes you're like, hey, I want to do this, and the model will say, yeah, I'll just implement it from scratch. And you look at the result and you're like, wow, that was actually pretty simple and easy. I would probably have reached out for a library myself, but you were right to actually do it from scratch. And I think that might push us towards a world where there's less reutilization and more coding from scratch things and repeating the same thing many times. And I do wonder how we encourage the models or the engineers to continue reutilizing, with the idea that if you reuse code in libraries, you reduce the number of bugs, you increase the number of eyes. There's lots of benefits to reusing code, and I'm not sure how we encourage the model to do that. So I was just thinking about that as you were responding.
Super interesting software supply chain point you make, which is that today you look at a web project and there's 600 dependencies, super poorly audited, some of them just written by a random person on the other side of the world with potentially unmaintained. Like, it's actually a software supply chain problem. And in a way, if you take, of those 500, 400 are either trivial themselves or you make trivial use of them, and replacing them with some simple self-written codes, if it's very cheap with AI, feels like overall supply chain win. So I totally agree that the trade-offs are going to change, especially as regulators push us more on software supply chain. But there's still a place for open source, right? There's
Yes.
still the other 100.
There's still a place, but what's the incentive that's going to encourage people to continue to contribute to open source if we live in a world where you can just ask AI to do stuff and it just does it for you? But like the supply chain issue is a major one. I mean, the OpenSSL bug, I don't remember if it was a year or 2 years ago, which was a supply chain issue, was a very scary moment for the entire community. And honestly, I think everyone forgot about it. We've moved on. So yes, we care more about SBOM these days. We talk a little bit more about that, and we're starting to think about it more. But I mean, it's an entirely different topic than open source and AI. But I think the role of open source, today it's enabling AI, right? Everything we're talking about is possible because there's a lot of open source code on the web. And the question to all of us, and I don't have the answer today, is how do we continue to build in a way that we continue to feed the AI and the learning process so that 10 years from now, we can still use the AI to code and it's still getting new content and new training, or maybe it doesn't need it anymore. I'm not sure.
One important thing to note, right? None of this AI capabilities that we've seen, especially the LLMs, would be possible without open content and open source, right? Like Sam Altman said last year that we're basically running out of data, and all the code that was used to create these models were open source. Some of them are GPL, and there's some licensing issues, but like without the entire corpus of open source software, there would be no AI capabilities. Now that may diminish over time as we have these foundation models that are already trained, and I don't know what the future around AI open source looks like in that context, but I think we're going to continue to have these problems that are common, and whether it's so cheap we can still throw it into an AI and get a good result, like still may make sense to always have these kind of corpus of software that's reused. Because if you're building an electric vehicle, oh my gosh, I mean, like there's lots of hard problems, and if the AI is so good it can do it better than anyone else, well, who's going to write the prompt? Right? Where are you going to go if you are a founding entrepreneur building the next e-bike? Like, how are you going to know what to prompt to, right? So you probably want to build off an open source EV set of libraries and frameworks and things like that. And maybe the AI is the one pulling it together, but I still think that I don't see a world that goes away.
I see two very important places for open source, even in a world when we can write big amounts of software automatically. The first one is that there's going to be a threshold of complexity. Like, nobody is prompting Linux from scratch, right? Nobody's vibe coding Zephyr from zero, at least not today. And I think not for a while, because even architecting that system well enough to feed it into an AI to get the code written is really, really difficult. And so some of these foundational technology above a certain threshold of complexity, database systems too, operating systems, programming languages, compilers, like some of these things are going to remain things that are shared artifacts of the software engineering discipline that makes sense as joint investments. And I think this is where open source really, really shines. Really complex systems that are so expensive to build that increasingly one organization is not going to build them on their own. There are living systems that improve over time where there's decades of use from those software packages and that are not well matched for simple AI writing. I think is good. The other thing we don't talk about enough is it's kind of the flip side of the software supply chain issue, that in some cases it's good to have known good things, right? Like a known good RTOS that is certified and tested and has been used by a lot of different people, so has had a lot of eyeballs on it. And yes, when you vibe code something, you write a library with AI, you might not have to put it in your software supply chain report, but the code quality problem hasn't gone away. Whereas a well-tested open source library with a software security program like that creates CVEs when there's an issue, while it adds to the complexity of a supply chain, it actually enhances the security and the quality of your product overall. And so I think those are the two places where these common pieces of infrastructure really ought to be open source. And I'm happy to see this happen in hardware. ThreadX become open source. I'm happy to see Micrium become open source. I'm happy to see Zephyr emerge and become one of the winners in the OS landscape. I'm thrilled to see Clang and GCC winning on the compiler sides, because I think that they've become shared wealth of the embedded software discipline that allow us to build better products faster, and I hope to see that continue.
Yeah, I think there's a lot of interesting points you're making here. I think another interesting thing that I'm seeing in the embedded open source world, since we switched to the open source angle of the discussion, is seeing more governance appearing. And I think one thing that's really interesting to see is how Arduino was probably one of the real first major open source project in the embedded world. And it's brought a lot of code, but not all of it was really high quality. I think we've all seen that. It was really the definition of the bazaar, like from the original article. And everyone was building their libraries in their corner, and there was no efforts to coordinate all of that. And then I think what we're seeing with Zephyr is a model where there's a lot more governance, a lot more effort to keep the code clean, to really bring those guarantees of code quality that you just mentioned. And FreeRTOS also brings those guarantees with a very different model, maybe a little bit more, centralized, but there's also the same effort to really provide quality, reviewed, verified code. And we're seeing more and more libraries that also do that. And I think that's definitely a great sign of maturity of open source in the embedded world.
The open source projects that will have value will be the one that come with governance and tests and rigor that makes them these trusted artifacts. Like just a random library from a random person is going to become less and less valuable as there's higher scrutiny and also lower replacement costs. But this is why, I think even Zephyr, I love Zephyr. We talk about it positively all the time, but even Zephyr has work to do there. For example, the length of their LTE releases, how often they happen, I think is a topic that we could talk about at length. Or also the fact that there's still not a ton of static analysis, for example, of the Zephyr code base. Let me tell you, I ran a static analyzer on Zephyr and I did not share the results because it was very scary. There's a lot to make these there's a lot more work we can do to make these more trusted, more reliable, and more valuable. On that note, and if you want to share something there, I'm very happy to have you.
I was just gonna mention kind of like, we're talking about kind of software as a single system, so like a software artifact and AI building it. But I think one thing that's kind of interesting, both of our companies here, right? We provide cloud services that go alongside a library that you can integrate, right? And so if you're having AI write, your firmware or something like that, you may choose to pull in one of these libraries to be able to talk to the cloud or something like that. If you kind of move up a higher level, right, you could say like, hey, agent, go and create this product that streams, whatever sensor readings up to the cloud and displays it in a dashboard to the end user. And here's your budget to do it. And that's where it gets really interesting, because what are the factors that are going to make the AI agent choose to put the credit card into Goliath, as opposed to into AWS, right? What is driving that? Is it because we have, a ton of open source software, and so
The
it's really
SEO.
easy for
Yeah, yeah.
Interesting.
yeah, it's crazy. It's SEO, but like the purchasing decisions eventually, it's like, you're not just bubbling up and getting mind share. You're actually potentially like, have a budgetary discretion of these agents that are choosing to do things. And it's not the same calculus you have right now. Like right now, of course, we think about giving the best libraries and documentation to engineers. We think about creating pricing models that make sense to business leaders. Are those things going to matter when AI is choosing, right? Or is it just like we're talking about, like maybe it'll implement it from scratch, or maybe it will choose a library, or maybe it'll do whatever, maybe it'll keep changing it over and over again because it's a vertically integrated artifact in its mind. Is the product vertically integrated as well? And how is it making the decisions about what to plug into that stack? So I think, both from like traditional engineering perspectives, but also traditional business perspectives around software, what is going to be the calculus in an AI model choosing your product? I think it's going to be interesting.
I'd like to take a couple questions. We have about 4 minutes left. The first one is from, and thank you, Dan. The first one's from Vrisal, who says that it seems like more and more engineers are moving towards higher level languages. Is this going to cause a problem in embedded engineering? And you can imagine these virtuous cycles of AI making Python programming, for example, easier and easier, having the opposite effect in embedded, making embedded harder and harder, and just continuing to raise the bar to becoming proficient in embedded compared to other engineering disciplines. Do you anticipate this as a problem? Is this something we should do about it? What's your take on that, John? Do you want to take that one?
Yeah, I think it's a cycle. I've seen this throughout my career. Mobile was very, very popular. When I joined Google, a lot of embedded engineers became mobile developers. And I'm seeing the other way around. Now a lot of web developers are becoming edge AI developers. And so I think it just kind of goes with as industry trends. As we talked about for the last hour, I think the definition of embedded engineer is also going to change. Those will have different compensation and career growth opportunities too. But it's a cycle.
Code is code. That's what I always say. Code is code. A great engineer can do anything. One of the best embedded software engineer I know is a trained designer who then was an iOS developer and then became an incredible embedded software engineer. And nowadays he writes web code. I mean, that's, this is, I think this is how we should think about our careers. Davide asks, how do you stay up to date with all these tools? This space of AI is moving so fast. Even and open source projects like Zephyr also change all the time. It feels like you're constantly catching up. Are there resources you recommend? Are there places where you get your information, Thomas? Do you want to take that one?
Yeah, I mean, I think this goes back to what we said earlier. You need to, nothing has changed. This was already true 20 years ago, 10 years ago. You need to make sure you reserve some space for personal growth and learning. And it's a balance, right? You could easily spend your entire time nowadays just playing with AI tool all day and feeling like you're doing work, but probably your boss would not be really happy about that. Your productivity would be pretty low. But I think you need to make sure that you save some time for learning. And so there's tons of great resources. I'm gonna pitch Interrupt, our blog. YouTube is an amazing black hole if you want to learn anything nowadays. And of course, side projects. I think there were some comments earlier in the chat by people who said, hey, my company doesn't let me push my code outside, so I can't use any AI tool. Then I think you should really use AI tools on side projects at home so that you have an idea of what's possible and you keep on learning. And then, you just find the right balance that works for you. And, if you're younger, maybe you have more free time, spend more time learning and playing with new tools. But even if you're later in your career, I think it's very important that you look at those tools and you stay open and you play with them because they're changing the world very fast.
I'll add one thing, and I know this is going to be painful, but get out and talk to other engineers in person. Go to the harder meetups, the embedded meetups in your community. Start one. I started one before the pandemic, and there's a couple in the Bay Area, but they're around the world. the YouTube, the Reddits, they're all great resources, but the best place I've learned about this stuff is actually talking to other people.
That's how I met
100%.
Jonathan.
Yes, exactly.
On that great note of wisdom, we're going to have to break. But thank you so much, Thomas, John, Dan, for joining me. It was a really interesting conversation. We could have gone another hour, as always. Thank you to all of you who joined us today, asked some questions, participated in the chat. We really loved it. Loved your comments and your questions. And you make this, worth it. You make it exciting for us to have these conversations. And, looking forward to the next one. Hope you'll join us. In the meantime, I want to wish everybody a great rest of their day and a good week ahead. Bye, everyone.
Thanks for tuning in to this Coredump session. If you enjoyed the conversation and want to dig deeper, check out more episodes available wherever you get your podcasts, on YouTube, or at memfault.com/webinars. If you have any questions for our team, drop us a line at team@memfault.com. Until then, keep shipping. See you next time.